Welcome to AP Environmental Science. In this video, we are going to briefly discuss the way that thermal inversions impact atmospheric pollution. Now let's remember, normally in the troposphere, as you get further away from the surface of the Earth, so you're increasing your altitude, the temperature is going to decrease. Remember, the energy from the sun turns into thermal energy as it warms the Earth, and that heat from the Earth is slowly released back towards the atmosphere. This causes those warmer temperatures near the surface of the Earth. Also, remember, adiabatic cooling is the phenomena where as an air current moves upward and away from the surface of the Earth, it is going to expand from the reduced amount of gravity, so reduced air pressure, and that expansion will lead to cooling of the air. In a thermal inversion, a warm layer of air ends up forming on top of that cooler surface air. So looking at our graph, instead of the air slowly getting cooler as you get away from the surface, we see a slight reversal or a stagnation in that trend. And this reversal in the trend, that is the inversion layer. Now this can form a couple different ways. Typically, this forms when a high pressure weather system prevents the air from mixing, or this results when a cool marine breeze pushes that cold marine air underneath the warm surface air. Regardless of how this is formed, usually that inversion layer will stick around until a large weather system moves through to force that air to mix back together and then settle back out in the normal pattern. The geography of a particular location also influences whether or not a thermal inversion is likely to form there. Typically, we will see inversions develop in valleys, particularly nested within mountain ranges. So what happens is as this warm breeze blows up and over the mountain, it's going to carry that warm air and have it settle on top of that cooler air that's tucked within that valley. This becomes an issue in places particularly like Salt Lake City in Utah. We also see thermal inversions develop when cold air from the ocean is blown inland and it pushes itself underneath that warm air from over the land. This is something that we will see in places such as Los Angeles. Regardless of how the thermal inversion forms, it has an impact on air pollution. With this warm air blanket, the pollutants are not able to continually rise and disperse throughout the entire atmospheric column. Instead, they are trapped underneath that warm air. So cities that experience these thermal inversions are going to have potential for really severe air quality issues. Now, in summary, you should be able to describe the difference between a normal tropospheric condition and a condition related to a thermal inversion. You should also be able to briefly explain how the geography of a location influences whether or not a thermal inversion will persist. And you should be able to describe how these thermal inversions trap that pollution to increase the impacts of that air pollution. Briefly, I want to point out these two pictures on our summary slide. The top picture, you can see smoke coming out from a chimney is being trapped by a thermal inversion and is spreading out horizontally right at the base or the bottom of that inversion layer. The bottom picture is showing Salt Lake City in Utah, and you can see all of the air pollution from the city is being trapped and is not able to escape upwards. So the people in that city are experiencing really poor air quality. Please leave me your questions here at the end. I will get back to you as soon as possible. And I hope that as you were able to watch this brief video, you were able to learn something.